The problem through which we will get more familiar with two-dimensional arrays is the one that you see on your slide. Like always, see the description of the problem and try to solve it yourself before moving on with our solution. We want to define a class matrix that has a constructor and a method. The constructor, all that it will do, as many other times we have seen, is initialize the instance variable of the class to reference the matrix that is passed into the constructor as a parameter. Now, from this description of the constructor, you should immediately understand that we also want inside the class to have a member variable that has the same type as the parameter of the constructor. We also want a sum method, and what it will do is that it will compute the sum of all of the elements inside the matrix. Before you go ahead and implement the solution, just take a look at the following two examples to make sure that we are on the same page. Here is one example of an array. We provide that array to our matrix constructor, and then we call the sum method through the matrix object. This should print on the screen 10 because the elements we have inside the array are 1, 2, 3, and 4. The addition of those has as a result 10. Here is a different example only because the arrays that are inside this two-dimensional array, so the one-dimensional arrays, do not have the same length. The first two have length 2. The first array has elements 1, 2, the second array has elements 3, 4, but the third array has 3 elements and the fourth array has 1 element. See that again our sum method should work regardless of how many elements are inside the subarrays. And the result should be 36. So go ahead and implement the solution to this problem. We have started our matrix class, and you can see already that in the main method we have included the two examples that you saw on the slides. So we will test our implementation with these two examples. We want to make sure that we get the result that you saw on the slides. Of course, we can more extensively test the implementation with even more examples, and this is what you should do. I will not show you in the video because we have limited time in the video. The constructor is pretty straightforward. We're just initializing the instance variable matrix, which we can access by this dot matrix, to the local variable matrix, which is the parameter that is provided to the constructor. So now the job that we have remaining is implement the sum method. It should return an int, which is the sum of all of the elements of the array. Notice that the array again will be a two-dimensional, so it will have rows and columns if you want to think of it as a two-dimensional, or in the more correct way to think about it, it is an array that has arrays as elements. How are we going to print the sum of all of the elements? We are going to have the following loop that will go through every sub-array of our array. How can we do that? We will have the variable I go from 0 until the matrix dot length. So we will go through every matrix element. And now, what is every matrix element? It is an array itself. So for every array, we want to access all of the elements that it has. So we want to access all of the elements of the subarray. And we're going to do it in exactly the same way. We will have another loop which will go through all of the elements of this subarray. Now, what is the subarray length? It will be matrix of I dot length. And then we increase j. And what do we want to do? We want to take this value, which will be matrix of I, so we want the jth value of matrix I. And what do we want to do with it? We just want to add it to our sum variable. Another way to write that, remember, is to say sum becomes equal to sum plus matrix. The plus equal operator, we have already seen it, and it is pretty much a shortcut. So this is all that the implementation of sum needs.